Welcome back to our tutorial series explaining how to take garments from CLO and bring them into Houdini or Maya to be processed with our carbon CLO garment processor, either welded or unwelded. In this tutorial here, we will now use the welded garment processor. So let's get started. I have a new Houdini scene and already saved it into my folder on the desktop. Now I'm going to create a subnetwork, which I do by creating a geometry. So I'm gonna change the name of this to simulation. All right, let's go inside and we create a file node to actually load the OBJ file of the mesh file. And we want t-shirt welded. There we go. If we go to the viewport and press space and A, we will see our t-shirt showing here. Let me click this to hide the UVs. Right click here, have a specular to get rid of some of those distractions. At this stage, it's also important to press space and 5 to check your UVs. This is the UV view, and you need to make sure that these are actually looking the same way they did in the pattern window. So if something went wrong, for example, you didn't tick unified UV coordinates in the export, they would all be overlapping each other, which is wrong. All right, this looks good. So let's press space and A. We're back in the 3D perspective view. Next, let's add another file node, and we want to bring in the avatar. Here's the avatar, and if I show the t-shirt over it, they're perfectly aligned. And that's what we want. All right, what's missing? Our FBX with the render meshes and details. So I press tab and I actually add a FBX archive import, which is a labs node, because it also imports the textures. I don't have any textures here, besides basically a white. So you might not even want to use this. It is really up to you. Optionally, you could use a file node, which doesn't really do all the textures, but it's simple too. So here we have our FBX and you see no textures. So it really depends on what you want to work with. The number of triangles is going to be the same. So the difference is if this handles the textures or not, if you want to handle them another way. All right. So since not everyone might have FBX, the labs integration installed. So let's get rid of the FBX archive import and just use a simple file node, which comes with the folder in Houdini. All right. Now, one more thing we need to do is split actually this geometry here into the render meshes and into our render details. How can we do this? It's a simple node called split. In Houdini, we create, a split node. And on here, we can now split the geometry into render and details. So we can either click on this to select certain primitives, or we use the drop-down and see if any of these settings can help us. So we see, for example, in shop material, we only have two options. We have default fabric, front, and material. So let's click on front. As it turns out, this is for all of the panels. And I guess the other one means it is the detail. So let's create a null node here. Put our display flag on it, we can see it is all the details. If I'm over the viewport and press space and A, it centers around all of the geometry that's in it, and we can see it is only the details. So that's great. Let's rename this one details. So we have a clear, a nice graph with good naming. And then here we create a null node too. And I will name this render. All right, one thing I like to do is press Ctrl S to save the scene from time to time to make sure I don't lose a lot of my work. Also, to clean this up automatically, you can press L and H when you're over this graph, and it automatically lines it up. All right, now let's create the garment processor. I've searched for the garment processor, and we have the garment processor CLO welded. All right, now for the garment processor CLO welded, we need to provide a few parameters here, and also later in the simulation setup the cloth material. So we can create this all now. Let's create a simulation first, carbon simulation, and set up the basic parameters. If you middle mouse button click on the avatar, we can see the avatar size is 186, which tells us the avatar was exported as in centimeters. So carbon works on meters per default, which means you need to change the length scale to adjust it to a scene length of centimeters. So this is done, setting it from 1 to 0.01, so the factor to convert from centimeters to meters. Also, I like to increase the subdivisions from 10 to 30 as a better base. All right, that's our simulation done. Let's add a default cloth material. And you might have some of the presets already that you can just load in here, or you start creating a material yourself. So we are in centimeters. The thickness default isn't for meters. So for meters, that would mean 1 millimeter. If you want to stick with 1 millimeter, so we just got to remove 2 zeros. So thickness 0.1 scene units and centimeters, 0.1 centimeters, which means it's 1 millimeter. All right. I like to increase my stretch stiffness to 100, viscosity to 2, and same for the bend viscosity. I think that's a pretty good starting point. Let's go back to our garment processor Welded. We now set the simulation node. And here we can pass on the XML file, which is our t-shirt welded metadata that we exported from CLO. All right. And before I forget about it, I'm just going to pop the cloth material in here, so it's done. Perfect. Now let's start working our way through from left to right. But first, we need to obviously attach our geometries. So garment processor Welded. What's the first geometry we need to attach? It says start panels. All right, we have our t-shirt Welded, which we pass in here. Perfect. Next up, we have our render panels. And the third one is render details. I can press Ctrl S again to save, and if I want this automatically laid out, I press L and H, and my graph is laid out. All right, now we look at our parameters for our garment processor. The first thing we can see is we have a guide visualization for creases, but obviously we don't have creases set up yet. So we look here in our tabs for creases. Color seed provides a random number as a random seed for your random color calculator, which you will see in a second. Group prefix, unless you specifically intend to do something else with it or it might clash with existing naming convention for you, I would leave it to default for crease underscore. Now let's create creases. Just press this button and it will automatically load information from the XML file and process it and apply the crease information here. So you can tell that there's now 23 creases set up and they are all visualized using this color tubes. If you had changed the color seed, so now if I change the color seed, nothing's different. If I clear this again and create creases, it will apply the new color seed, so the colors will be different for all of the creases. But usually I just keep it default. Default, revert to default 0. We can get cleared and create creases. You can see it's pretty fast. All right, so what can we do with these? So first of all, for each of them, you can enable and disable. What does a crease do? A crease applies the strength and the angle of a fold in CLO for each of these lines. So the values from CLO have been exported to XML. That is what the metadata file is for, and then imported into this node. So angle is in degrees, and per default, what was exported all flat, because we didn't specifically set any angles in CLO, so all of them are 0. Now, if I'm playing around and set this to 180 or 50 or 30, and at some point I'm like, actually, I want to reset it to what the file was, you can see in brackets XML equals 0. So I know, that was it. So I can go back to 0. Same for strength. All right, now I can click on the color button and change the color. As you can see, the color for this crease is changed. If you want to manually set colors for individual creases. In the visualization tab, if you go back up here, you can set the thickness. So 0.01 is very small, or we can just grab here and set it very thick. If you work in centimeters, 0.3 seems to be a very good value. I would stick with it. Also, you can change the visualization from a single crease, which you can see is crease 1, and so on, and scrub through. Or you go back to all creases. This just allows you to kind of simplify the viewing. Now, next thing, you might ask yourself, well, how do I know which one of these corresponds to these easily? Because some of the colors look very similar, and I'm not quite sure which one of these corresponds to these. That's a good question. And we have added some groups to actually help you find this. So what you need to do is you go to Select. Then here in the drop-down, you go to Geometry Groups. And let me make this bigger. You see this pop-up window now. And we actually have a group for each crease. So if you hover over these, it will start selecting or like highlighting them in the viewport. You can also do the other way around. You can click or hover over on the viewport and it will highlight on the right side. So this way you will easily see this is crease 18. What is this? This one is crease 6. And then you can obviously go down here to crease 6 or crease 18 and you can change the parameter values. All right, if you want to get rid of this, click on this button and it changes. So it removes this and we can go back to camera view. All right, this is our crease setup. I'm actually quite happy. I don't want to change anything. Should we move on? Yes, but let's save first. Control S, saved. All right, let's go to simulation setup. We've already passed our cloth material. All we need to do is click on Create Simulation Subnet. This will create a new network here, which is named based on a carbon carbon clow garment processor name, and it will inside have the one cloth that holds the welded mesh. So what happens here under the hood as well is it takes the original geometry and it creates a remeshed geometry using the carbon remesher. The carbon remesher takes geometry, provides a new geometry as an output, which is friendly and suitable for carbon simulation to help you support using anisotropic parameters, so weft, warp, and bias. If you use default Delaunay triangulation, it will still be applied, but not as well or strongly as it would if you have geometry coming out from the carbon remesher. So normally you don't have to edit much here. You can just basically just stick with the default setup, and you have this linking the cloth material. So all you need to do really is change your parameters in the carbon cloth material here. That's already linked, so you never really have to actually go inside this subnet, which is quite neat. All right, so we have our simulation setup here. We have our cloth. What we need to do is to obviously connect our cloth to the carbon simulation. Put our display flag in the carbon simulation, and there we go. Carbon simulation initialized. Go to carbon simulation. We can reset again if you want. Press play, and there we go. Our outfit, our t-shirt is falling down under gravity. Obviously, we now need to add the avatar. Click on this, add a merge node in the graph because you can only put one input into the carbon simulation. Connect this to the avatar, and in between here drop a collider node. Carbon collider. Now carbon collider, similar to cloth, the default parameters are meant for centimeters. So we might want to adjust our thickness, let's say to 0.1, so 1 millimeter, same as the cloth. We can also untick animated geometry because our avatar is not animated. Go back to the simulation and press reset. And here we go. We have our avatar and our garment, and it's simulating nicely. Now you can tweak your simulation as you please. Play with the cloth materials, play with the avatar, play with the simulation settings. At this point, I like to press L and H again to lay out my scene, so it's a clearer graph. And I also press Ctrl S to save my scene. If we're happy and we only want to use the simulation meshes, we're done with this tutorial. But we actually exported render meshes and details. So how do we apply these now? It's quite easy. We go back to the garment processor, put our display flag on it, and we move to the next stage, which is the mesh deformer stage. This will create a mesh deformer setup. So all I need to do is press create deformer setup, and we actually see there's an issue. This is very, very big. Now let's see what this is and how we can fix it. If I go inside this deformer setup, I can see my deformer main. So this is for my render panels and deformer details. So the deformer main maps my fig render panels to my simulation mesh based on the reference panels. And then as input here, we have obviously our simulated t-shirt, as you can see. Now the second deformer takes the output from our render panels, so the 3D, which unfortunately is not very pretty, and then projects or like maps our details, which are here with this deformer. So now why do we get this, let's say, ugly output? Well, this is very easy. It is because we need our render panels, our flat render panels that we exported from CLO. We need them to match or to overlap our simulation reference panels. And these are thin. So now if I show the reference panel and then I press the pink flag to show the render panels as well in wireframe, we see they do not align. So why is this? If a middle mouse button click here, I can see that there's a center of Z equals 20 on this. So unfortunately, the way CLO exports these flat panels is always with a value of 20 in the set. So let's go back up. Let's go here. We have our render meshes, and we can just add a transform. Transform. And we want to remove the set, so we go -20. Now it moved. If you show here, disable, enable, you can see that it moved both the render and the details. Now we can go back to our render meshes, our render meshes, and we see nothing has happened yet. Well, this is because we haven't updated the mappings on the garment processor. Under the Mesh Deformers 2 section, there's a new mapping and update all mappings. So nothing has happened yet, so we click update all mappings. The mappings have updated and now the correct values are being used. One thing to note as well is that there might have been normals on the original file. In order to apply the correct normals, we have two options. We can either delete the normals on the mesh, or we can just overwrite them with normals that get updated every frame with a normal node. So I can just set this normal node, and we can play with the cusp angle. Usually I just dial it up all the way. Now I might also want to add a merge node and just merge this actually with the avatar. There we go. And now we have our avatar and our outfit. And let me actually move this on a different screen. We can see that it simulates and it renders properly. Yes, and this is the basic setup. And again, I might want to press L and H maybe, or not, depending on how you like it. Or I may set up the graph, Control S to save my scene. And here we have our setup of our welded carbon cloak garment processor using the avatar and the t-shirt. Thank you for watching, and I hope you have fun using this new tool.